Hello, my name is Jack Zamudio, and I am a sophomore studying mathematics with aspirations to become a physician. I also have an officer position on the club swim team at Chapel Hill. This past semester as a ULA has further motivated me to continue helping students as a ULA. Chapel Hill's chemistry students are some of the hardest workers I have seen, and I see myself in many of the students. Taking chemistry at Chapel Hill was certainly an adjustment for me, and I have sought after the guidance of many ULAs throughout my time here. The opportunity of being a ULA is fulfilling because I feel like I'm able to pay forward the guidance that I sought after and continue to seek as a student. I will help students develop better learning strategies by promoting a growth mindset and sharing effective study strategies. I recognize that the essence of learning chemistry comes from understanding concepts and not memorizing problems. It is important to express to students that they must take initiative in their learning and to embrace the challenge of studying chemistry at Chapel Hill.
Boric acid is frequently used as an eye wash to treat eye infections. The pH of a 0.050 molar boric acid solution is 5.28. What is the value of the Ka for boric acid? The first question that we're going to ask ourselves is, what do we have in solution? And so here, all that we have is our concentration of boric acid, which we can represent with Ha, and our solvent, water. Now, the rule of thumb is that our strongest acid will react with our strongest base. And here, our only acid is our boric acid, and which will react with our water, which will act as a base. And so we can write the reaction Ha plus water will react to form A minus, the conjugate base, and hydronium. And so we can use an ICE table to help us visualize what exactly is going on in this situation. And so we can say I, our initial concentration, C, our change in concentration, and E, our equilibrium concentration. And so with the information that's given to us, we know that we start with initial concentration of boric acid of 0.050. We don't need to consider water because it's a liquid. It won't affect our Ka expression. And we know that we start with zero concentration of our conjugate base and hydronium. Now, change in concentration, we're going to have some of our Ha that reacts to form some concentration of our conjugate base and our hydronium. And our equilibrium concentration will be our initial minus our change, and this will just be X for our A minus and H3O plus. And so we can write a Ka expression, which is a ratio of our concentration of products over our concentration of reactants. And now sometimes we're given a Ka, and we use that Ka in this expression to solve for our X, which will tell us what our concentration of H3O plus is and allow us to determine pH. However, here we're not given that Ka value, but we are given a pH. So we have our pH of 5.28, and with that, we really know what our concentration of hydronium is, as pH is our negative log of our concentration of H plus. And so we can say that our concentration will be 10 to the negative 5.28. This will give us a concentration of 5.248 times 10 to the negative 6 molar. And so we can use this value to substitute in for our X's to solve for our Ka value. So 5.248 times 10 to the negative 6 squared over our reactants. And this will come out to a Ka value of 5.5 times 10 to the negative 10. We report our answer to 2 decimals because we are limited by our initial concentration of boric acid given. Thank you.